Buster Posey just hit a home run. Game 4. Put the Giants up 3-2. This could be it. Top of the 6th inning. Anyway, classifying. Last Advanced Algebra Chapter 3, Lesson 1. The last video we're going to look at how to classify these systems. You can classify a system by the number of solutions that it has. So this is how we're going to classify it. We're going to classify these systems based upon how many solutions that they have. Now, when we've been graphing these equations, you'll notice that lines can only intersect in one point. And that should confirm to you what we did in geometry in previous years, that if two lines intersect, it's only possible for them to intersect in one point. However, there is one place where it can have more than one intersection, and it's kind of a technicality type thing, but when we're looking at a system of two linear equations, it does become a possibility. So the three types of classifications are independent, dependent, and inconsistent. Okay, so what we've been looking at so far are getting one unique solution to a system. So we're going to label that type of system an independent system. So if the system has just one unique solution, which we've been doing in this last lesson, you graph these two lines, they get one solution. If they intersect at all, there's only one. That means these two lines are intersecting. They only intersect in one point, so there's only going to be one solution. And so this would be a picture of what that would look like. The second type of system that we have is called a dependent system, and this is a system that does not have a unique solution, meaning it has a solution, but it's not just one point like we have in our independent system. So the dependent system, there is no unique solution. In fact, there are infinitely many solutions, because what we have here, we are talking about a system, so we are talking about two equations, but it just so happens that those two equations are actually the equation of the same line. So if you graph those, you actually have a line on top of a line, and it's actually therefore intersecting at every single point. Therefore, you have an infinite number of solutions because you actually have the equation of the same line, and so when you graph those, you're actually graphing a line on top of a line. So there isn't one solution, there's an infinite number of solutions. So we call that a dependent system. The last type of system would be an inconsistent system, and this is a system where you don't have any intersection points at all. You're talking about parallel lines, and remember, we can tell parallel lines by looking at the slopes. They will be the same, but remember, the second thing we have to look at is the y-intercepts. Those have to be different, because if it was the same y-intercept, we'd be talking about this dependent system above, because we'd actually be talking about the same line. So three types of systems: independent, where you have one unique solution; dependent, where there isn't one unique solution but actually infinitely many solutions; and then the inconsistent system, which are two lines that are parallel. There are no intersection points at all. Now, we can do all this without actually graphing them, because all we have to do is look at the slopes. Let me go back to what we're looking at before here. Let me pull all these up really quickly here. The intersecting lines, remember, they are going to have slopes that are different. Okay, slopes that are different will be an independent system. If we're looking at a parallel or line on top of a line, we're going to have the same slope and the same y-intercept. If we're looking at inconsistent, we're looking at same slope but different y-intercepts. So all we have to do is have the equation in slope-intercept form, and then we look at the slopes, and then we look at the y-intercepts if they're the same slopes, and by looking and evaluating those, we can determine these systems without actually graphing. So the equations have to be in the same slope or slope-intercept form. The independent system will intersect, therefore you'll have different slope. The dependent system will have the same line, therefore you're going to have the same slope and the same y-intercept. And the inconsistent system are going to be parallel, which means you're going to have the same slope but different y-intercepts. Notice that these two have the same slope. So the only way to distinguish between a dependent and inconsistent is to look at the different y-intercepts. So that will be how you'll have to do that. So here's an example where we classify it without actually graphing. So again, we need to put it in slope-intercept form, so we're going to rewrite both equations in slope-intercept form. We're then going to check the slopes first. The slopes are the same, so that means we either have a dependent system, a line on top of a line, or an inconsistent system. So we'll look at the y-intercept to determine the difference. The y-intercept is a 3 in one and a 1 in the other, so because they have the same slope but different y-intercepts, they are parallel, which means this is an inconsistent system. Okay, so we can go ahead and here I have 3 examples. You can go ahead and do each one of those on your own. I'll reveal these answers one at a time, and so you can do those, stop the video, and then check it out for yourself.